Alright, ladies and gentlemen, this is going to be a short video in a longer series of videos, and I'm going to do the write-up on it later because I know that my dialect, my Southern West Virginia dialect, is a problem for many of you. Can't seem to get past the old country boy voice to accept the signal, the information. So that's why I'm going to do a write-up. I always do a write-up. I've been writing a lot longer than I have been, doing video on the subject matter anyway. So anyway, now in this demonstration, I was going to use the real-world application or mechanism of a auto transformer to demonstrate something to you about gravity. Now, all you electricians out there know that should know anyway that an auto transformer has a single winding. It's one coil. And there's no primary and secondary like in a transformer. There's just a single winding. Now, so that and a single winding here will serve our purpose in a direct current scenario or an alternating current scenario. Now the only difference being is our points of reference are going to be different in the direct current than they are in an alternating current. If this winding is fed, okay, now let's go over the three scenarios. We're going to say this winding first is fed with the phase-to-phase voltage of a three-phase distribution system. This is a phase-to-phase voltage of 480 volts. Okay, now in that case, these terminals, these leads, let's say this is all you electricians took the electric motor up, it's terminals 1 and 4. Okay, your A-phase winding. Now, back in the generator, okay, these two terminals. See, the conductors of a circuit are simply an extrusion or an extension of a boundary condition that was created back in the stator field of the generator. Okay, the windings, see, the conditions of an open circuit, when you have an open circuit there, before the switch has been enclosed, now it's connected back through the other end through the windings of the stator. The stator windings are connected. So that gives us our displacement. Now, voltage or an electrostatic potential is a longitudinal displacement. It's a scalar potential. People have referred to it as scalar wave, but it ain't no wave. It's a instantaneous action in distance. What I'm talking about here, folks, it's a longitudinal displacement in the dielectric medium. See, all matter is a positive potential energy, which has displaced the medium. Okay, it's displaced the dielectric field medium in the same manner that the girth of a ship displaces a body of water when it sets in. Okay, now there's pressure, there's a back pressure that the body of water exerts on the hull of the ship. On both opposite ends of the hull, the body of water exerts a back pressure or a potential. Okay, now that body of water, that back pressure is counterbalanced by the material of the ship and the atmospheric pressure, which is a scalar potential. Atmospheric pressure and electrostatic potential are both scalar potentials. They're static. They have no kinetic component yet. They have no magnetic transverse component. Right? So now in the example of an auto transformer that's fed with 480 volts phase-to-phase voltage, in a three-phase system, these terminals are actually going to be displaced. We got a displacement in the medium of 120 degrees. Because, again, this is all based on the circular function, the 360-degree rotation of the generator's rotor inside the stator field. So it's based off the circular function of the generator. Okay, in all electromagnetic induction, whether it's a direct current transformer or not, before it can be how it comes out of the stator field, it's collected on the stator field as an alternating current. Okay, and then a commutator is used to rectify, just like, well, this is actually a clever little device that tricks the field. It keeps flip-flopping. But the potential is collected on the stator in every generator as an alternating current. Because if there was no 360-degree rotation, is what produces the maximum positive and the maximum negative voltage. The sine wave is a product of the 360-degree circular rotation of the generator. Okay, so now, on a single phase, with a single phase supply, residential supply, or a portable generator, for instance, we don't have 120-degree displacement. We have 180-degree longitudinal displacement of the medium. Okay, now what do I mean by longitudinal displacement or scalar potential is, say this is a piece of rebar, okay, or metal pipe or whatever, and I smack it on one end with a hammer. Well, the energy transfer is immediate, instantaneous action at a distance. Okay, is what I'm talking about in voltage or scalar wave, scalar potential. It's not a wave level, but it's longitudinal rarefaction and compression. It's a compression wave. Okay, and that is potential. That's static potential. A tree falling in the forest, that old question. If no one's around, does it make a sound? And again, I've answered that question ad nauseum, and no, it doesn't, because there wasn't an eardrum to react with, and sound is a reactance. Well, when the tree falls, it creates a longitudinal displacement. It has no it's not a vibration yet. It is a static longitudinal displacement. It doesn't become a vibration until it hits your eardrum. Right? So, that's what we have with voltage. We have a static displacement of the dielectric medium. Okay, now, again, all matter is a positive potential. It's a positive potential energy which has displaced the dielectric medium, just like if you can visualize this as a two-dimensional 2x2 piece of elastic. And, I drop a steel ball down it and I've displaced it. Right? But if the only thing we got is that steel ball, every piece of matter has displaced the medium. Say we got one big piece of matter called the Earth, and then we got 7 billion more little small pieces of matter walking around on it that's displaced the medium too. Human beings. So all matter has displaced the medium. Okay. I think that's what Einstein meant by general relativity and special relativity. I don't know what the hell he meant, but that's what I mean. I mean all matter. Okay, so now in the example of this auto transformer right here, we've got one primary, we got one winding. There ain't no primary and secondary. There's one coil here. Okay, now our points of reference are going to be different if this is fed with alternating current, because 0 point in an alternating current system is going to be right dead center of the coil. Because in an alternating current, if this is fed with an alternating current supply, this winding is experiencing a sine wave. There's a sine wave. There's a sine wave on 2 axes, but this is what that winding is experiencing. Okay. Out here, it's experiencing on 2 different axes when it's under a load. Okay, we have 2 different axes. 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 We have an oscillating sine wave, or we have a sine wave that's oscillating between the terms. And we have a sine, when it's under a load, when the circuit's under a load, we have a sine wave that's oscillating out here in 3 dimensions as well, called a magnetic field. We have an alternating, when the circuit's under load, we have an alternating magnetic field, which is an outwards displacement of 3 dimensions. And we have also a inward force vector. It's not a force vector, it's an acceleration. It's the exact opposite of force. It's an acceleration back to 0 point. It's an acceleration back to the point of 0 potential. We have away from 0 and back towards 0. Okay, we have an outwards displacement and an inwards acceleration or displacement. Okay, now, so the only thing that's going to differ is if we feed this with an alternating current circuit, our point of 0 potential is going to be right dead center of the winding. So we're going to have a maximum positive voltage from the top of the winding to the center of the winding. And from the bottom of the winding to the center of the winding, we're going to have a negative voltage, maximum negative voltage. But the point of 0 potential is right dead in the center. And then from each end of the winding, each end of the coil, we're going to have an end phase voltage. We've got a 180-degree displacement. Now, this is a single phase now. Now, it's different with the three-phase system because the three-phase system is based off of the 360-degree circular function of the generator. Okay, and 360 degrees subdivided 3 times, that means the windings are displaced 120, 120, 120. That's 360 degrees. Okay, so now in a 480 volt system, a phase-to-phase voltage is 120 degree displacement. Okay. We've chopped this one 360 degree cycle. One 360 degree rotation is 1 hertz. So hertz are a measurement in seconds. Okay, RPM is a measurement in minutes. So hertz is directly proportional to RPM. It's a circular function. Okay, now what you do in a Y-configured system or a delta-configured system, your points of reference from phase to phase are 120 degrees displaced. 120, 120, 120 is 360 degrees. So a phase is simply, A phase is, see, A phase, B phase, and C phase are always going to be at a different potential. And I'll go into why that is, but you see. So a phase is just one point of reference in the 360 degree cycle. That's what a phase angle. It's an angle. So, but now back to the auto transformer right here. So, now if we feed this with a direct current, okay, our 0 point's going to be down here. We ain't going to have no 0 point dead in the center here. Our point of 0 potential is going to be the other end of the, from here to here. So, it's a static displacement between the terminals. It's a static displacement of the dielectric medium. That's why your voltage, every electrical rotating device, whether it be a generator or its inverse, an electric motor, all those systems, again, are a circular frequency. A direct current has no frequency. Okay, a direct current is a unidirectional displacement of the dielectric medium. It's a static displacement of the medium, longitudinal. Okay. There's no outwards force vector. There's an inwards, you might say, vector. But you don't even have that inwards vector, that inwards acceleration, until equilibrium is disturbed. And equilibrium in the system is not disturbed until the source comes into contact with the load. So this potential, there's a difference of potential between the 2 points in 3 dimensions. Okay, between the 2 terminals, there's a potential. And that will remain at equilibrium up into its capacitance. When it reaches saturation point, see, a capacitance is the dielectric storage coefficient. It's how much electrostatic potential can be stored within the medium. Now, the medium ain't got to be the atmosphere. The medium can be glass, whatever. Glass is even better than the atmosphere. The medium, okay, the medium is another example of the medium is, again, I've used the body of water as an example. Now, you know, the open air with no clouds in it, that's the medium undisturbed. Okay, the pond, sitting still before you throw the rock in it, that is the medium undisturbed. Your mind, when you fall into it, when you fall into a deep sleep, that blackness where there is no time, that's your awareness. That's a field of awareness. That's a field as well. That's your field of awareness undisturbed by thought. That is the pond before you drop a rock in it and disturb it. Now, when you do disturb it, however, when you do drop a rock in it, there's a longitudinal static displacement that reverberates out in all directions, concentric circles, if it's based on, concentrically. But it's a longitudinal displacement. It's not a vibration yet. It's a static displacement. It's a scalar potential. It's not a vibration until it comes into contact with matter. Okay. So, but before we can disturb the dielectric medium, we got to have a rock to drop in it. We got to have a rock to drop in the pond before we can disturb it. Now, once we drop the rock in the pond, we start rotating a magnetic field inside of a generator. Now, if there's no other point of reference, if there is no stator, if there was no stator there to boundary this displacement off, there'd be no reactance. Okay, so there is no, all this shit I was talking about with an open circuit. An open circuit is a boundary with one open end. Right? It's connected back at the other end through the stator field of the generator. The windings are connected. So, but until source reacts with load, there's no magnetism, nor is there any acceleration back to, because they're sitting at equilibrium. Equilibrium has not yet been disturbed. And with a ship, there is an equilibrium between the body of water that it's sitting in, the matter of the hull of the ship, the metal, and the atmospheric pressure. It's a counterbalancing between 3 things, or 3, they're not things, but 3 forces, for lack of a better term. Atmospheric pressure, the matter of the ship's hull, and the body of water. It's creating a back pressure on the hull. Now, when the ship's anchored, sitting still, the medium's at equilibrium. The medium, the ship, and the atmospheric pressure's all They're counterbalanced. They're balanced, sitting at the point, they're at zero potential between them. There's zero, it's your feet standing on the ground. Just like when your feet are standing on the ground, there's zero potential between the bottoms of your feet and the ground. Okay? However, between the top of your head and that ground that your feet are standing on, there is a difference of potential. Magnetostatic, electromagnetic potential. There's an electrostatic and a magnetic. Magnetostatic potential between the top of your head and the bottoms of your feet. Okay? And that's that's gravity, ladies and gentlemen. Just like voltage is the difference of potential between 2 points in 3 dimensions called the terminals of a circuit. Well, gravity is the difference of potential between 2 material points as well, between you and the earth, between the top of your head and the ground that your feet are standing on. There's a difference of potential as well. There's 2 points. Before you can have voltage, before you can have a difference of anything, you got to have 2 points of perspective at least. And before you can have reactance, you got to have 3. See, so there ain't no magnetic field, point being, there ain't no magnetic field manifesting around this coil until you put the instrumentation on it and measure the voltage. That's when you get a magnetic field. Now, what I was going to show you with the auto transformer. Now, say this is direct current, okay? And I've said repeatedly that magnetism reacts back on the conductors of a loaded circuit in the same manner that a water tower reacts back on water lines to pressurize them. Say that they lose the pump, but they got to lose pressure. There has to be a change in the equilibrium. Equilibrium in the system has to be disturbed before there'll be any reactance between the water tower and the line. There has to be a disturbance in the equilibrium. Okay? So, until we put an instrumentation on it, put a meter on this thing, it's equilibrium, might as well say. Okay, and there ain't no magnetic field reacting or manifesting. Well, maybe there is. But it ain't exert no force against nothing, because there ain't nothing. Before you can have a force, there's got to be 2 things. There has to be 2. There has to be one to feel the force and the other to exert the force. You have to have 2 points of reference, just like you do with a voltage. And with gravity and G-force and all that shit, there's a point of reference between any 2 pieces of matter. There's 2 points of reference. So there's 2 points of reference between me and my old lady that's sitting over here. There's a difference of potential. She's displaced the medium and I've displaced the medium. And I got to exert a positive force to close that gap. The gap between us is space, the distance that I have to walk. That is the difference. That's the gap that's being closed in a short circuit. But anyhow, so all matter, to give consideration to matter without giving any consideration to the dielectric field medium is no different than giving consideration to the writing in a book without giving any consideration to the white page that it's written on. And, all matter is the writing. It's anchored to the dielectric medium in the same manner that the writing on the page is anchored. The writing's anchored to the page in that same manner. We're the writing on the page. All matter is the writing on the page, and the page is the dielectric medium. Nothing. The point of zero potential. So now when a ship displaces a body of water, the counterbalancing between matter, there is no reactance until the ship's motor applies a force. And, it creates the illusion of the ship traversing through the medium. But when it's anchored off, sitting still, it's at equilibrium. The matter and the medium that has displaced, the medium and the matter which has displaced it are at equilibrium, and the atmospheric pressure. There's a counterbalancing, and equilibrium is called buoyancy. Just like there's a counterbalancing in an internal combustion motor between pressure, volume, and temperature. There'll be an explosion when equilibrium between those is disturbed. And the equilibrium between the volume, temperature, and what was the other? Volume, temperature, and mass. Volume, temperature, and the medium. So there's a counterbalancing between three things there. Just like there's a counterbalancing between matter, magnetism, and electrostatic potential in an electrical system. So I done went on for 26 minutes.